Hello everyone, I am very happy to join to that conference. Now I introduced my presentation. It's about synthesis and characterization of nano, copper oxide, zinc oxide and aluminum oxide catalyst via laser ablation route for preparation of some cyanoacetanilide derivatives. That is presentation by Ahmed, Musbah, Sarhan, MSc students at Port Said University, head administrator at Delta Company for Fertilizer and Chemical Industries. Now, I send many great thanks to my professors, Dr. Farid Ibrahim Al-Dsuqi, Faculty of Science, Port Said University, and Dr. Amr Abdel Ghani, Spectroscopy Department, National Research Center. We talk about laser ablation. Now we know as laser ablation is technique or new technique, physical alternating technique used for synthesis of many of the catalysts. Laser ablation is considered for and promising effective route to be used for creation of nanoparticles. It is the technique which used to preparation of nanoparticles of many solid. Heterogeneity of sample was examined to show the basicity and to confirm the high catalytic activity, and that catalyst may be used to applied in chemical reaction which give us high yield and short interaction time. When we use nanoparticles as a catalyst in chemical reaction, it increases the surface area, which may cause low time of reaction and high yield of product. Now we transfer to another slide. The main goal of my study is synthesis copper oxide and zinc oxide and aluminum oxide nanoparticles in aqueous media using laser ablation route to deionize the water. The laser ablation technique carried out at 355 nanometer. That is eco-friendly technique. In the other way, it's safely environmentally. And the fourth generation of the catalyst nanoparticles with spherical shape. The range of nanoparticles diameter is about 20 to 50 nanometer diameters, as previously reported or for different material. Now we get to the preparation of 2-cyano 2 para-nitrobenzalidine para-methoxyacetanilide. It is one of the acetanilide derivatives. It is one of the acetanilide derivatives which we have many applications in our life. The new nanocatalysis, copper oxide, zinc oxide, and aluminum oxide by prepared percentage used for synthesis of that product by reaction highly wide range called novel gel condensation reaction. Novel gel condensation reaction between para-nitrobenzaldehyde and the 2-cyano in 4-methoxyphenyl acetamide compounds. We know about novel gel condensation reaction. It actually carried out over activated methylene group. Now we use this property to linkage between the catalyst and the activated methylene group and formed our, as we show in that equation. Acetamide compound react with para-nitrobenzaldehyde in the presence of catalyst to get the acetanilide derivatives. Acetanilide derivatives may have many applications, and we show in the next slides one of the greatest applications that we applied in our reaction, and that mechanism which illustrate the combination between the catalyst and the activated oxygen in carbonyl compound, which give negative charge, and that activated methylene group to get our. This protocol used to obtain high yield of final product. The method of considered is solvent-free, eco-friendly as we said before, short time reaction, and excellent yield in comparison between that catalyst in bulk form and nano form. We get in our studies that nanoparticles get wide range and high surface area, which allow us to get high yield, and the attraction between the reactant get faster than in the bulk form. One of the greatest application which used for our product is the antibacterial effect. Acetanilide derivatives had many applications, but one of the greatest applications which may used with widely range and give effectively yield is antibacterial effect. We introduced our product to two microorganisms, one called Streptococcus bacteria, that's gram-positive bacteria, and the other called Enterococcus bacteria, which is gram-negative bacteria. We have a product which synthesized by organic catalyst called piperidine, and the other product which synthesized by the nanoparticles. Here we have one effectively point. The effective point or the main point is that piperidine is organic catalyst which may contamination with product because we can't separate it from the product. But our catalyst can separate it mainly and get the product in pure form, so it get highly effective to antibacterial and get the greatest antibacterial effect than one used for piperidine. That is indicates that we have inhibition rate for our product. The two products which we used in that study is the acetanilide derivatives made by piperidine and the other made by using nanocatalysis. We get that the one which applied to Streptococcus bacteria give 50% inhibition rate, and that by piperidine compound, and the others which made by nanocatalysis it give 90%, that is the doubled inhibition rate than one for piperidine compound. And we get the other microorganism, Enterococcus bacteria. We get that the component or the product which made by piperidine, it get 50% for inhibition rate, and the other of nanocatalysis get 90% double yield as the previous one. And that is the greatest use for the product which made by nanocatalysis. And finally, get many thanks from me to all of you, and thank you for being one participating in your commit. Thank you, and get you in another commits. Goodbye. Thank you.